GI Bench is the latest multifunction software package developed by Gantner Instruments, and it can be used for all configuration, visualization, and logging tasks related to Gantner products and services. GI Bench is considered a software package as it contains several component applications, and each is independently responsible for several core tasks. In this video, we will focus on the component application called GI Data, GI Bench's platform-independent data manager. With GI Data running on a network centralized server, or PC, it is possible to merge time-synchronous measurements from multiple buffers into a single data source, which can be visualized on a single chart, or logged to a single file. So why is the ability to stream and merge data from several sources a useful feature to Gantner customers? To answer this question, we will cover the general benefits of merged streams and how the merging process works. The ability to stream data from multiple sources and merge the time-synchronous measurement values is a functionality enabled by GI Data. This functionality complements the scalability of Gantner solutions by providing the necessary flexibility to accommodate any application, big or small, fast or slow. By merging multiple data streams into a single data source, potentially thousands of measurement channels, regardless of the devices they belong to or the sampling rates used, can be synchronized to a single timestamp, visualized on the same chart, and logged to a single file. For example, applications that involve several channels of measurement data collected at various sampling rates will require more than one buffer in the project configuration. Similarly, applications that involve several channels of high-speed measurement data, depending on the total quantity of channels, may require the use of multiple buffers or even multiple controllers to do so. In either example application, the data is collected using multiple data sources. Therefore, merging the data streamed from those sources can potentially simplify the logging and visualization processes by ensuring all the collected data is synchronized, visualized, and logged as if only one device performed the necessary tasks. Merging data streams is most often only necessary if using multiple timesync test controllers for a single purpose. However, it is also possible and sometimes important to merge streams from multiple buffers within a single test controller. In either case, the desired data must first exist within GI Data in the form of a stream before merging is possible. Each buffer of each Gantner test controller must be a separate data source streaming into GI Data. Once all the necessary streams are within GI Data, then the streams can be merged into a single data source with matching timestamps across all channels. In this video, the Q.station controller will be used to demonstrate the creation and merging of multiple data streams. If you require guidance for merging data streams using other controller types, you may contact your local Gantner Instruments technical support specialist for more personalized assistance. There are three main prerequisites to be mindful of for the merger of data streams to work properly. First, you can only merge streams that share a common timestamp. Combining data with dissimilar timestamps is not possible. Therefore, you must synchronize all connected Gantner controllers before attempting to merge streams. The best synchronization method for merging data streams is Q-Sync over RS485, which guarantees synchronous data with a jitter of less than 2 microseconds across all connected devices. While the accuracy provided by Q-Sync is essential for merging data streams in general, it is also particularly important to use in applications that require highly distributed setups to perform simultaneous measurements or actions. Two things are required to utilize Q-Sync for the synchronization of multiple Q.station controllers: wiring and configuration. For the wiring, you will need to connect the screw terminal pins labeled SYA and SYB to their matching counterparts on all Q.station controllers. With the Q.stations wired properly, each controller can then be assigned their respective synchronization methods within GI Bench. The setup will follow a master-slave structure, where one Q.station will be assigned the role of the master, and it will use its internal clock as its timestamp. The remaining Q.stations will assume the role of slaves, where their distributed clocks will be forced to match within 2 microseconds of the master, and thus each other. To configure the master Q.station in GI Bench, double-click on it within the project configuration tree. In the controller settings window that appears, select the Synchronization tab, and configure the type field as None, indicating that the Q.station will receive its timestamp from its internal clock. For the slave Q.stations, you will need to configure each individually. Double-click on the slave controllers within the project configuration tree. In the Synchronization tab, configure the type field as Q-Sync over RS485, indicating that the slave Q.station will receive its timestamp from the connected master controller. After writing the above configuration changes to the Q.station controllers, your Q.station network is ready for streaming data and merging streams. The second prerequisite pertains specifically to merging data streams from multiple controllers, and that is, all controllers that are to be synchronized must have a matching system variable named timestamp within their project configurations, and each timestamp must include the specific arithmetic formula text, timedc. It is not sufficient to have a timestamp in your project configuration that is defined only as a cycle counter. The specific arithmetic formula text, timedc, is required for a stream merger to work properly. The formula timedc stands for the time distributed clock, and represents the absolute time since the 1st of January in the year 2000. The third prerequisite is something to be mindful of when determining if a merger is appropriate for an application, and that is, when attempting to merge data streams sourced from multiple buffers, the resultant stream can only have one sample rate. In other words, if you attempt to merge multiple streams of dissimilar sample rates, the sample rate of the resultant merged buffer is determined by either upsampling or downsampling at least one of the dissimilar sample rates. To explain that a little more, upsampling will result in the same value filling the merged buffer n times to achieve faster sampling effectively. Conversely, downsampling will result in only every nth value filling the merged buffer to achieve slower sampling effectively. Therefore, it is recommended to ensure that merging streams of dissimilar sample rates will make sense for your post-analysis in the first place. Only certain selections for the sample rate of a merged buffer will be possible, and these selections can vary depending on the sample rates of the data sources selected. You do not need to be mindful of selecting the correct sample rate for the merged buffer. Instead, you may select a desired sample rate from the list of possible options. GIBench will only present the user with viable options. To demonstrate this, here's an example. If we merge two data buffers, one sampling at 10,000 Hz and the other sampling at 100 Hz, then a common sample rate for the merged buffer is required. From the list of possible sample rates presented in GIBench, we see 1000 Hz as a viable option. If we select 1000 Hz as the common sample rate, then the merged buffer will include every 10th sample from the 10,000 Hz buffer, and all samples from the 100 Hz buffer 10 times each. The result is a merged stream providing 1000 points of data per second per data source, with all data points possessing matching timestamps. It is ultimately up to the user to determine how insightful merging data of dissimilar sample rates can be for them. It may only make sense to combine the data sampled at the same frequencies across multiple buffers to eliminate the potential risk of nonsensical post-analysis. With all the prerequisite knowledge covered, we will now explore how to create the desired data streams within GIBench. Within GIBench, there are three levels where you can make configuration changes to a project: the PC level, the controller level, and the module level. You can observe these levels in the general structure of the project configuration tree, where the project itself exists on the PC level. Also on the PC level are the elements system streams and data logging. By right-clicking on the PC icon labeled Project at the top of the configuration tree, you can add additional elements to the PC level. Data streams can only exist on the PC level of a project and will appear under the element system streams. Merged streams, once created within a project, will appear under another element called merged streams. The process of creating either individual or merged streams is an operation that occurs within GI data. For multiple streams to be capable of a merger, the streams must first exist within GI data on the PC level. Creating the necessary streams can be done automatically while reading a pre-configured controller within GIBench. To do this, ensure the device is configured first. Then create a new project within GIBench and click on the Read button on the configuration toolbar. Select the connected controller and click OK to add it to the project. Eventually, you will see a window labeled Select Streams for visualization. In this window, select the desired buffers to be streamed into GI data and click OK. Individual streams will be created for each measurement channel within the selected data buffers and will populate the System Streams element within the project configuration tree. This method is by far the fastest and easiest to use. You can otherwise create system streams manually. This process entails manually adding a data stream for every buffer from where the data is to be collected. To do this, right-click on the System Streams element within the project configuration tree and select Add System Data Stream. You will see red symbols appear indicating that the newly created stream must be further defined. To configure the stream, double-click on it to access the Stream Processor Settings window. There are many configurable settings within the Data Stream tab, But for this demonstration, we will only focus on the fields labeled controller, access type, and stream. The controller field defines the device that contains the target data buffer. The access type field should be defined as high-speed port data buffer to allow access to the target buffer's data. The stream field is used to select the target buffer containing the desired data. Next, click on the Available Variables tab. Here you must select either all or only some variables to be streamed. To minimize the PC performance required by GI data, ensure to select all channels, as selecting only some channels will require GI data to parse the stream for the selected channels. When finished, click OK to complete the system stream configuration process. You will need to create a stream for every buffer across all devices, and this needs to be done separately from fully configuring all systems. Therefore, it is recommended to fully configure all the connected systems, then reread them into a new GI Bench project to automatically create the desired streams. Once all the desired streams exist within the project, GI data is then ready to begin merging them. To create a stream merger, right-click on the PC icon labeled Project at the top of the configuration tree and select Add Merge Data Stream. Doing this will create a new element on the PC level called Merge Streams, and within it, an unconfigured Merge Data Stream. To configure the newly created stream, double-click on it to access the Stream Processor Settings window. Several settings can be defined here, but we will only focus on the few that need to be configured in a certain order. First, define the count field with the necessary quantity of streams for the merger, and press Enter on your keyboard. The necessary quantity of fields will appear below based on the value entered. In the fields below, define the streams that you would like to merge. The selectable streams will be listed using their generic names. You may reference the generic names of each stream within the name column of the project configuration tree. You do not need to select streams in any particular order. After defining the streams to be merged, you can then select the sample rate of the merged stream in the cycle frequency field. As mentioned previously in this video, all of the sample rates seen within this list are valid selections. Therefore, if the selected streams contain data measured at dissimilar sample rates, then the cycle frequency field will only provide commonly valid selections for the resultant sample rate depending on the native sample rates of the selected streams. Once the desired cycle frequency is defined, click on the Available Variables tab and select the variables you wish to merge. Please keep in mind, only selecting some of the variables listed will require additional PC performance, as GI data must further parse the streams for the selected channels. When finished, click OK to exit the Stream Processor Settings, and then save the project. Now that we have all of our desired variables contained within a single synchronized stream, we can use the merged stream as a data source for the visualization and logging of said variables on the PC level. To do this, create the desired functionality on the PC level within the project configuration tree, such as a logger, and select the merged stream as the data source. By selecting a merged stream as the data source, all of the measurement values from the variables contained within can be recorded synchronously to a single file as if collected from the same device, regardless of what device or set of devices collected the data originally. Once you have configured the project as desired, save it, then click on the Data Acquisition tab located above the toolbar at the top of your screen. You will need to activate the GI Bench project before proceeding. By clicking on the Activate button in the toolbar, your GI Bench project will transition to a live status, thus initiating all configured visualization and logger functionalities. If your project includes a logger configured as continuous, once the project has been activated, you will immediately see logger files in the storage directory you defined. If the project contains other logger types, such as triggered or event-based, then data will be recorded according to the logger's configured settings. To visualize the merged data, click on the Graphics button in the toolbar, or press the F5 key on your keyboard. Next, click on the three lines adjacent to Tab 1 at the upper left corner of the dashboard. This will open the Dashboard Designer. With the Dashboard Designer open, you may freely create, resize, configure, and delete visualization elements within your dashboard. To get started, find the desired chart element within the Dashboard Designer and use the drag-drop method to place it on the dashboard. You may then freely expand the element as desired. Next, under Variables, you will see folders for each data stream and merged stream you created. Expand the folder for the merged stream by clicking on the arrow next to it. All of the variables selected while configuring the merged stream will be listed below and available for assignment. Similar to placing an element on the dashboard, to assign a merged data stream variable to an element, use the drag and drop method. After doing so, you will see the desired signals visualized as waveforms within the element. You may then click on the gear icon at the upper right corner of the element to further define its settings as necessary. Contact your local Gantner Instruments technical support specialist if you require assistance with the creation or merging of data streams within GI Bench, or if you would like information regarding the various products and services Gantner Instruments has to offer.